There we go. That should be good now, right?
Yeah,
I'll
it
ask
should be
Vika
good
just to load this new recording. Aprajito, I've been thinking about why there's no correlation, and maybe we can talk about that at some point.
Right.
I think I have an idea of what's going on.
I know I was, I know I told you about trying the other method with the 2D spectra. I haven't really gotten to that yet because I'm, getting ready for the grad school applications.
Okay.
Yeah.
No, I have
So,
a simpler idea, very simple idea actually, but let's
right.
come to that in a minute.
Yeah.
Okay. So we are on these. We're observing. We're taking 2 more exposures, 20-minute exposures of an N31 mask. The mask is N31 SPI, shown here. And or is this our 6th, 7th for tonight? Seventh mask for tonight, and then we'll observe an 8th mask after this. That will be in the galaxy M33. This one will run for another 40 minutes or so, 2 20-minute exposures. And then we'll go to the last mask of the night after that. Last mask. It will take us through to about 4:30 p.m. our local time. Ricky, did you need remote control of my screen for some reason? I don't think I should do that because, we have telescope controls. I don't think I can do that. So, Aprajita, how you were looking at slits that where I have marked versus I haven't marked?
Yeah.
You're looking at their intensities. One thing I was thinking is I only detect this when the H alpha and 2 sulfur 2 emission is not uniform along the slit. If it's perfectly uniform along the slit, it subtracts off beautifully and I don't see it.
Right.
So maybe comparing the overall strength of H alpha and the sky spectrum, plotting that against the intensity of the map might be a better metric, just to see if there's any correlation at all between those 2 quantities. That is, in the sky spectrum that we have, there should be an H alpha line. And looking at strength of that H alpha line versus the strength in the map might be a better metric, a better way to test whether there's any correlation between the 2.
Right. Yeah, I wonder how we can do that. So,
Well,
let's look at the histograms one more time.
Yeah, not in terms of the histogram. I mean, each for each slit, you have a measure of the map H alpha strength, and then you also have an H alpha emission line in the sky spectrum of that slit. So, just looking at those 2.
Yeah, I mean,
I was thinking.
But like if we are going to read the H alpha density from the spectra, then I think we can just make a histogram out of those.
Right.
I don't think we need to bring in the image in that case. Like
Well,
that,
I was
I
just
think
thinking
that's
that
enough.
this way, the image, we were going to use the image because that's an automated way of deciding which ones have H alpha and what the strength is. That's the only reason.
Yeah, but if we can, I mean, we can also automate it using the spectrum.
Yes, true.
Uh,
True.
if we can automate the process of measuring the H alpha, which of course we have to, then yeah, we can do the same thing except for the uh, except for using the image. I mean, that's what I was planning.
Right. Since you have the the image-based H alpha at some point, just seeing whether the two relate to
Yeah,
each other or not.
absolutely, absolutely. We already have the code, so yeah, sure, we can compare it at some point. Um, I mean, my basic plan was to look at the 2D spectra,
Okay.
because something I've noticed, while looking at all the 1D sky spectra that we had, is that it's not that great at measuring H alpha. Uh, uh, it's not that representative of the H alpha uh, for the entire slit. Sometimes, on some occasions, um, like what I mean is that the reduction pipeline looks at the 2D spectrum and it just picks one like average 1D
Yeah,
sky
true.
spectrum,
True.
right?
It's an
And
average, yeah. It's average
right,
over the slit.
yeah. So like that average might not represent like the brightest parts of the slit, like the brightest parts of the H alpha emission in that slit.
True.
And that sort of leaves a little bit of room for error sometimes because I have seen some H alpha lines that had some weird shapes in the 1D spectra,
Mhm.
stuff like that. So I think maybe a slightly more robust way would be to add back the sky spectra to all the rows of the 2D spectrum,
Mhm.
and then to do a continuum subtraction for every single row to get rid of the target
Yeah.
continuum,
Target
and
answer.
then just
Yeah.
and then just collapse it into a 1D spectrum because we have the
True.
tilt. We know how to read that from the files. We have the tilt, so we can just collapse that along that line somehow. I haven't fully figured out the math for that yet, but yeah, that should be possible. And then we already have some code for measuring the flux intensity using a
Yeah.
simple Gaussian fit-in. It's a
Right.
single
But
Gaussian.
Operator, just one quick
Yeah, yeah, yeah.
interruption. If you took the 2D spectra as they are, which are sky subtracted, and you
Yeah,
remove the continuum from that, and you just collapse that,
right.
that plus the sky spectrum should be the same as adding the sky
Oh
back
yeah,
by row.
true, true. Yeah, that's less computation. Yeah, for sure. Yeah, that's what we should do. You're right.
But I'm also thinking
Uh,
that even that may not be necessary because what it's subtracting off is an average sky spectrum. And by definition, the residuals will add to zero once you collapse them.
um, true. Like that is what should happen. Yeah, I
Yeah.
guess we need to run some
That's why I was
tests and
thinking
make
that the
sure that's what's happening.
yeah, that's why I was thinking that the sky spectrum H alpha
Yeah,
should be a good
you
measure.
do bring up a good point. Yeah. But no, I'm not sure how the average was calculated, right?
Yeah, if it's a
Because I'm not
median
sure
versus an
about.
average, yeah, exactly. If it's a median versus an
Yeah,
average, I think it does take a median sky, not an average.
yeah. Yeah, if it's a median, then there could be some residues. I suppose.
Okay, so let's see. I just want to take a quick moment to
Yes.
Ron, you and I haven't met, but I understand you're a high school student who's working with Lara and Carrie on the outer M33 masks, right? Isn't that
Yes, that's right.
which grade are you in?
I'm in my senior year, 12th grade.
Oh wow, okay. And let's see, Rick, how did you find out about us? Hi, Rick. How did you find out about Shadow the Scientist? Yeah, I can't hear you. Sorry.
You can type in the chat if you want.
Yeah.
Yeah, let me just type it out in the chat.
Thanks, Prajita. Wrong, I assume you found out from Lara and Carrie that we're doing a shadow session tonight.
Yes, I did.
You must be busy with college applications.
Yeah, but I managed to kind of time manage in the summer, so it isn't as bad as in the school year.
That's
So
good.
it isn't horrible, but it's definitely a
good.
lot.
Oh, it's a lot of work. Yeah. And Ron, you're working with DEIMOS. Are you working with catalogs? Are you working directly with Spectra?
I think it's just catalogs at the moment. Like the main data that I have is like the FITS file that has like everything. I don't think I'm working with the direct spectra. I don't think,
Okay.
but yeah.
Okay.
Not yet.
Oh, there's Lara.
Wow. You might be in the future though, Ron. Hi.
Hi.
Please turn on let me show you our video panel. There we go.
All right. You can actually see that.
And they could see us before we could.
Right.
Abhijit has also been working with DEIMOS spectra of M33 and M31, mostly M33.
Yeah. Have you heard from Liv, Raja? Have you heard from Liv since?
I have heard from her. At one point I sent her an email about there's a former UCSC undergraduate who has written a paper on Wolf-Rayet stars, and that was not the main thrust of her thesis, but she had written this paper, and she's connected me to two astronomers I know quite well who work on Wolf-Rayet stars. So I asked Liv whether I could share some of the some of the Bell spectra with them, and she said yes. And I haven't had a chance to package that up and send it off to them.
Good. Yeah, I haven't heard from them since SIP. I have been, yeah, I took a few weeks off after SIP
Okay.
ended. So yeah, then I started working. But yeah, I need to meet with Liv and discuss some of these ideas find out what's going on with bells. And yeah, I mean, we are both like, and we are both now working on sort of different projects. Like, so yeah, I mean, that's what we are talking about near the end of set that, yeah, we miss collaborating more. So yeah, I mean, it really helps if you have somebody to, to bounce ideas off of.
True.
So yeah.
Operator, when are your grad school
yeah.
applications? Are they in like December?
Yeah, I've been checking the deadlines. Most of them are December, mid-December.
I see.
I think Leiden is probably the 1st of December, or it might even be the middle of November.
I see.
Yeah, I will confirm it soon. Yeah, I've just been, getting everything in order. Sending out emails to my former teachers, making sure, trying to, find out how many recommendations they can provide.
Okay.
Yeah, because that would, how many applications I can submit will depend on that number. Yeah. For now, I was just updating my CV, sending out a few emails to some of the programs. I sent one to UCSC. I have not heard back yet. Hopefully, I will hear back soon.
What haven't you heard back from UCSC? Sorry.
So it was something about the transcript.
Okay.
Basically, UCSC asks for a WES evaluation of your transcripts if you are an international student.
I see.
So because my university did not use a 4.0, sorry, I mean a 4-point GPA grading scale.
Right.
Like I have to just do my best and do a reasonable estimation of what my GPA could be.
I see.
Which is still not perfect because, as you know, scores are not, we are not graded on a curve here.
Right. Realize that.
So, yeah, it's not really representative.
Mm-hmm.
But yeah, so that was basically my question. That
CCD readout complete.
What happens if the WS evaluation does not match my estimation? And what happens if the WS report falls short of the 3.0 GPA minimum? Because if that happens, that will happen after they've made an offer for admission. So yeah, I wrote to the graduate advisor. I think his name is Brandon, right? Brandon
Day. Yeah.
Yeah. That's the contact that was listed on UCS website. Yeah. So I'm waiting to hear back. I'll probably send a follow-up email next week.
Okay. That's good too.
So what's this mask targeted? I know it's M31 mask,
Mhm.
but like what kind of objects are we looking at? And well, I mean, which region of M31 are we looking at?
So this is the region in the south part of the disk, not far from where M32 is. That's the region we're looking at here.
Oh, is that why it's M31S?
South, yeah, exactly. That's exactly why there's the S there.
What does the I stand for?
The I at the very end is the location of the mask. A, B, C, D, E, F, G, H. We have these, mask orientation and
So
location.
you have an uppercase B. That's
Ah,
also
yeah.
for the region, right?
No, the uppercase B. So S is south. Uppercase B means it's we're using a blue grating, meaning a 600 CD grating as opposed to a red grating.
Yeah.
600 is in the blue. I mean, not quite in the blue part, but it's a bluer than 1200.
Yeah, it covers the bluer
The
part
blaze.
and yeah.
Yeah, the blaze of the grating is really the 600 ZD. 600 is of course a number of lines per millimeter, but yeah, the 1200G grating is blazed to 7500.
So we've got about 15 minutes until we reach the elevation limit for this target, so we might not get through this full
Okay.
second integration.
And Tony, what we've been doing usually is actually waiting for it to get to elevation of 36.8. And as soon as the alarm goes off, we'll pause and read out the exposure.
Okay.
If that's okay.
So you basically just want to write down.
Right down to the end, yeah.
Yeah.
Sorry, you go.
I'm sorry, I was just going to say, I mean, we might do it. The limit numbers are a little, they're not exactly accurate. It's not like when we reach exactly like a
Right.
zero.
Right. It usually lets us go 2 or 3 minutes beyond, so we might actually finish the exposure.
Yeah.
The FCS has had this error, warning. It hasn't actually updated itself in a long time because it keeps saying, "Oh, I think this is should we be concerned?"
So the FCS isn't running at all?
Well, it keeps trying.
Oh, that's
Yeah, it's been happening.
last hour.
Since we've started, every so often it would get one.
So we're having a little bit of an instrument issue.
I don't know how concerned you should be about that. Too versed on the side with this. See if I can get. Something called FCS fix, which has worked in the past.
I remember something like that, FCS fix. So we're having some trouble with the flexure compensation system for folks on Zoom. This is the thing on the right part of the screen. It's trying, but it's not working properly.
Yeah. It seems to be stuck on the x-axis. But it's moved around a lot.
You mean no, but that's old. What it's showing is an old trace. It's not currently up.
Oh.
You see it says FCS status seeking, it's not tracking at the top. And it gives a warning.
Yeah, I see a ticket with the similar behavior from FCS. It gets stuck seeing here like this first. And there's a ticket here on how to fix that. Better running.
Sounds good. You can do that.
I think so. I don't see why not.
All right. Then we should do the next.
Yeah, so you can actually do it because I don't have actual
Okay.
your DEIMOS GUI, but and this is actually a ticket from Michael. Fix FCS from the DEIMOS instrument control GUI actions drop down.
Okay.
Yeah. Is he saying?
Drop down to the FCS out of the state.
Any guesses, Raja?
I don't remember. I have very limited experience with. I remember there was an fix FCS script, but I don't know what to do after that. You could try getting FCS images. Hmm. Sure, let's do that.
Yeah.
Where does it show emergency?
It's come back. Now it just is off topic.
Okay. At least it's back to trying to track.
Yes.
This is a huge improvement. Okay. So it's moving the green thing back into the pink box. Yeah.
Very. Yes, you know it pops up in the see.
Yeah, I see that.
My guess is it's first stage because that's my normal.
Yeah, I don't normally see that as red either. Yeah, I know what you mean. It still hasn't moved into the box, but it's getting closer. So for the folks on Zoom, Ali and Rick, I didn't understand your answer. How did you find out about Shadow the Scientist? And same question for you, Ali. How did you find out?
It's really getting stuck because it's not moving.
Right. Yeah, it's sort of it's going horizontally.
Yeah, so I see some other tickets with this issue for viewers in like a negative
23.
In the past, let's see, Carlos adjusted the grading offsets. Oh, here, no. I unclamped and clamped the grading at the destination PA. Fixed the problem.
I do that.
Yeah, probably to do that target exposing.
Oh, I see.
Well, I'll write up a ticket with this behavior. Hopefully it's not a totally lost exposure. So the first behavior, it was stuck it was like seeking, right?
Yeah. Yeah, when it was stuck earlier, it was just seeking.
Or was it trying to think?
Seeking, I thought.
Right. Yes.
So now the FCS looks yet, well, maybe it's just a display, but it's still above the box as like before.
Yeah.
Oh, I see. So it's really not being nudged back into the box.
No, not
So Rong and Aparajita, of course, I know you guys and how you found about Chat of the Scientists. But for Rick, Ali, and Dhruv, I'm curious to hear how you found out about Chat of the Scientists. If you could please type that into the chat, that'd be great. All right, I'm going to check on the data copying and see where that stands. Okay, so it's copied over all of night 1, but it hasn't copied over the log, so let me do that. Okay. 36.8, I thought was the elevation limit, right, Tony?
What's
It'll give you an alarm at that point.
We should be okay. Right now, 36 points.
Oh,
So we're gonna lose it any second.
so should I point to the next target and we'll zoom and then we'll go?
Exposure complete.
Yeah, I think that's a good idea.
1600 ZD, right? Same as
Okay.
Yep, I am slowing now. I'm gonna rotate. Rotate.
DCD readout complete.
that's good. Yeah, yeah.
Oh, but the data, data.
I see. The one in which the,
Okay.
I see.
Okay, that's a bummer, but yeah, I've noted that in the ticket, so yeah, we lost that.
We may have gotten two good 20-minute exposures and just lost the third, hopefully.
We're at this new position here we're guiding, so yeah, go ahead with the alignment.
So has the FCS thing fixed itself?
Possibly. Raja, get me. Sorry.
Sorry?
If you can start maybe.
Oh, I'm sorry, of course. Sorry about that.
Okay.
Okay, it just does this.
Exposure complete.
It was silly. I was trying to copy the log file for night one over to my directory from Keck, but it's already in my directory. I don't need to copy it from Keck.
DCD readout
I got it directly
complete.
from the web and I put it in my web page. So, okay. Sorry. Okay. What number are we up to? Actually, I can check. Don't worry.
Exposure complete.
Hey, Rob.
Hello.
All right.
DCD readout complete.
Base marker.
Okay, that's 8:40. You'll have to do it because I can't access. Oh, I can access the log, I suppose. Yeah, I can do that. Which window is it in? Is it in that? Not in one of these. Let me check. Usually it's in one of these windows. This is not a bad one, is it? The one we're looking at, Lara, is not so.
So this is one. This one. One was where we started becoming
Okay.
actually.
Oh yeah, actually it's blurred because there was movement in the spatial direction. Yeah, but this looks like an X shift, so maybe the coordinates they're talking, the Y they're talking about is really a spatial coordinate.
Yeah,
Oh, you have, okay. see. Okay, that makes sense. Can I steal the mouse back?
Yes.
So we are actually near the end of the night, and well, not quite near the end of the night. We're about half an hour away. You can see if we go to the telescope status that one of these windows, it says that time to limit is 40 minutes. So we should be able to, for the next 40 minutes or so, we'll be able to observe this target, and then it gets too low in the sky, and the telescope will hit a physical limit and can't keep tracking it. Just stop my screen share for, oh, actually, I need to stop my screen share. I'm going to check on my.
Is the FCS fixed?
The FCS seems to be working now, but it ruined one of the exposures. So we've got 2 out of 3 20-minute exposures. The third one seems to have been ruined. So we'll still be able to get velocities and stuff from that one.
Yeah, that reminds me that, yeah, that's something I have to remember when measuring the H alpha, because the exposure times could vary a little.
They do, but the way Spec 2D at least lists the spectra, it's supposed to be electrons per hour.
Oh, true. Yeah.
So in Hawaii, now it is 4 a.m. on Sunday. On Saturday, from 10 a.m. to 3 p.m. on the Big Island in one of the cities, Kona, they had an event that they have every year. They've had it for the last several years. It's something called Astro Day, where all the telescopes that are represented on Maunakea and many other organizations that are sort of space related, and even some other science related organizations put up tables. This is in a mall in Kona, along the, right outside where the shops are, entrance to the shops are. And they set up these tables. So we had a shot of the scientist table there. Jamaica had set that up. And then there was a Keck table, of course. There's tables from all the observatories. So I was hanging out at the Keck table some, and then also at the shot of the scientist table. It was nice to be able to say to people, we run Shadow the Scientist session, and at 8 p.m. tonight, we're going to run a session. So So something like 8 people, parents and children, found out about shadow that way just a few hours before the session, and they showed up in our last shadow session.
It's interesting, this place in Hawaii called Kona, because yeah, there's a place called Kona here in Hara.
Really, Kona.
Yeah,
Kona means corner in Bengali, right?
yeah, right, that too.
What is the origin of the name Kona in Hara?
I'm not sure. But like there's an expressway there, and yeah, it's called the Kona Expressway, which is mainly the reason the name comes up
I see.
often. Yeah. Yeah, we have taken it a few times returning from some places in Kolkata.
I see.
It goes through Shatragachi and surrounding areas.
I see.
I'm sure there are other places there, but yeah, Shatragachi is the only one I remember because yeah, that's where they have the big lake where you get to see all the birds in winter.
I see. I don't know this place.
Yeah. Yeah, it's not far from Kolkata. Like, and that's basically why Shatragachi is famous among nature lovers and other nerds like me, because yeah, it sees huge flocks of migratory birds in winter,
Oh,
mostly waterfowl. Um, but yeah, a lot of other birds too. Um, it's in the middle of an urban area, like next to an urban area.
I see.
So, of course, there's a lot of pollution, and for decades there have been um, campaigns from environmentalists to preserve the area, to find best practices to you know maintain the habitat, to make sure that the birds keep coming.
I see.
But yeah, it's really interesting. I mean, the whole thing, and it's basically one of the biggest congregation of like winter migratory birds in, let's say, like southern Bengal.
I see.
Uh,
And what is it called again?
it's called Shatragachi.
Shatragachi. Because there's Bharatpur is, of course, a well-known bird sanctuary in India, right?
Right, right.
Where is that located?
It's in Odisha, if I remember correctly.
Oh,
Let me
not that
check.
far away from Bengal. Okay.
Oh, it's Rajasthan.
Rajasthan. Okay. Okay.
Yeah, that's really true. Yeah, I was probably thinking of Chilka.
Oh, Chilka is, yeah, it's a lake, of course.
Yeah, there are other locations in North Bengal, but yeah, that's basically the biggest location in South Bengal. And I mean, you can tell, like, the funny thing is that, in the years whenever, all the birds don't go in Shatragachi, or like some of the birds don't go to Shatragachi in one season,
Exposure.
we'll see that they end up in other locations throughout South Bengal. So, if Shatraj has seen fewer birds, I'll probably find more closer to home, like near my town.
Wow.
Yeah, and the habitat is like really interesting because like the lake is full of water hyacinths, right? Kochuripan.
Mhm.
So obviously that's an invasive species in the Indian subcontinent.
What is it? I didn't understand what's the invasive.
The plant, Kochuripana,
Oh,
which
okay.
is water hyacinth.
Water
And,
hyacinth. Okay. Okay.
right, yeah. That's
DCD
invasive
readout
in the
complete.
Indian subcontinent, right?
Mhm.
So, since the lake was covered in the weed, they decided to take it all out a few years ago, like as much as they could. And surprisingly, the birds hated that. Like, even though it's not natural, like, they liked the water hyacinth because, like, that's literally what they got used to. So the new strategy is that they remove some of it and they tie the rest of them together into these little floating islands that some of the birds can land in, rest in, and even nest in.
It's very convenient, huh?
Yeah, I haven't been out bird watching in a few years, but that's kind of like my second nature-related interest, if you count astronomy as the first.
Yeah, I remember you telling me that. So yeah, FCR seems to be behaving okay right now. Or I'm stealing the cursor. And is this the frame we're looking at? Has very little continuum, is that? Well, that's probably because these stars are faint. And this is we're going to do we are doing very long integration, right? This is her third. Well, you're observing this mass, but she's observed it for 2 half nights and will observe it for a third half.
Yes.
And these
Wait,
also are central masses. Right, sorry, Rajita, go ahead.
did we lose another CCD again?
Yeah, that same CCD5 has been flaky.
Oh no. Yeah, it was back last time I was on SDS.
Yep,
No, not
last
last
year,
time I was on
all of
SDS, but
2022B, it functioned
yeah.
fine. The part of 2021, even I think it might have been okay, but this problem started to happen in 2019, and they tried to fix various amplifiers, etc., and it came back, but then it started flaking again a couple of weeks ago, I guess. seeing is not that great. I guess I'm going to take a quick look. It's not terrible, but you've seen better. Oh, no, it is bad. 1.2. It's not going to help with this very faint stars. That's part of the reason why we can't see anything in these slits. All look about the same. Of course, of course. No, that's good. I was just messing around. Nothing useful. Okay. What number are we up to? 10. Wrong left and said, hope the observing goes well. That's okay. That's reality. That's reality.
I think it's
Mhm.
coming behind us.
But certainly if it's a 1200 line grating, then only the red arcs.
No, so these were 2,600.
So for the 1200 grating, it never came back.
No.
Okay. Yeah, then but he would want blue and red because they get reduced together
Okay.
because it reduces the CCDs 1 and 5 together.
Right.
So it makes sense to get the fourth set. Yeah. Harder to mix and match that.
Yeah.
Because the way the plan file works for the reduction software, it says, give me all the ARC files.
Mhm.
And what will happen then is it'll have ARC files where there's no CCD5, even though the science frame does. And then there'll be some ARC files that do have CCD5 and won't be able to. It could run into problems with that. Better not to give it. If we do have CCD5 in the science frame, better to give it calibration with CCD5. Full set of calibration with 65. So I think that's what he had in mind.
Yes.
Parajita and Rob, we're sort of looking at some very faint, a mask with very faint stars in it, because we know we're going to get really long exposures for this mask. So we wanted faint stars in there, faint red giants. So it's a little difficult to see anything much in a single 20-minute exposure, like you're seeing in this frame. There's very little. You can see the night skylines, but very little else.
Exposure complete.
You can see continuum in these slits, but it's very faint.
Yeah.
Also, the seeing is really bad, so that it doesn't help.
Oh,
I mean, really bad by Keck standards.
I wonder if there's a way to find out the shape and the location. The shape, the orientation,
PCD
and the
readout
location
complete.
Of the slits?
of the slits from
Yeah,
the
that's
reduced
actually-
data.
Yeah, it's actually
Or like-
relatively easy to do. The 1D spectra, the header of the 1D spectrum
Right.
tells you, let's see, it has coordinates of the target, or
Right.
index of the target, and then it tells you how far above and below the target the slit goes. Above and below meaning along the slit direction. And of course has the position angle on the slit. So we know the exact rectangle. And Amanda has used this information from the Spec 1D file header to overlay the slit on Hubble Space Telescope images.
Let's see if I can find them.
Okay.
So I know the area and depth of the object. Of
But you want to draw a rectangle on the H alpha image.
Yeah, I mean, I was thinking of giving that a try. Basically, yeah, exactly what you
That's
described,
interesting,
like drawing a
because
rectangle on the shelf image. Yeah.
one interesting thing that might emerge from that is if you get the intensity of H alpha as a function of position along the slit, basically you'll get a small rectangular map, right? You'll cut out a rectangle out of the H alpha map.
Right.
It'd be interesting to see whether whether the map has variation along the slit, because we do see variation along the slit in the DEIMOS data, and whether those two things line up with each other. What we're seeing from DEIMOS, 2D spectrum, and what we're seeing from the H alpha map.
Yeah, true. I'm also not sure which one has the better resolution.
Sorry, you're not sure? Say that again.
Which one? I'm not sure which one has the better resolution.
Oh, yeah.
I think it might be Keck,
I
right?
think it
Because Keck,
might well be.
yeah, is really powerful. It has a big mirror, so I mean, there's a chance that maybe like drawing the triangle, drawing the rectangles will only cover maybe like 2 or 3 pixels on the image.
On the ground-based image, yeah. In that case, it may not be worth doing anything with the rectangle.
Yeah, that's probably a better thing to check first. But and now, let's see.
Stop my screen share.
I need to go back to the FV software. Let's try out TopCat.
What top? Okay.
Yeah, I was trying out TopCat, but it seems to give me a bunch of errors. It shows me the data, but yeah, so that it's a bit harder to navigate. I was using the software called FV, open source.
FV?
Yeah, FV.
What does that
It's
stand
open
for?
source.
Fitz
I
viewer?
don't know.
Fitzviewer, I think.
Probably FV.
I'm pretty sure I've come across FV as Fitzviewer. I'm pretty sure.
Yeah. It's hosted by NASA. The problem is the Windows version is kind of old, and the UI is kind of bad.
I see.
Here it is.
Ruchita, do you have much experience programming a graphical user interface?
Not really. Like the most I've done was, trying some interactive stuff with the Matplotlib. Literally nothing beyond that. So yeah, basically nothing.
Oh,
Um,
yeah, I mean, interactive
Yeah.
with Matplotlib is a good beginning, of course.
Yeah, I mean, like DS9 works really well for image fetch files, but for some reason, I found it harder to get good software with good UI
Mhm.
and that is compatible with all the files I use.
Gotcha.
Okay, I'm looking at the headers. Let's see. I know RA_OBJ and DEC_OBJ are the RA and DEC of the objects.
Say the names of the variables again. I didn't quite get it.
RA_OBJ and DEC_OBJ.
Okay, OBJ. Wow, okay.
Yes. Yeah. I've been using those two variables to, read the H alpha data from the images.
Okay.
Let's see. There's a bunch of other stuff. Let's see what could be the usual suspects. Oh, there's a variable called parang, P-A-R-A-N-G.
Parallactic angle?
Maybe the description doesn't say anything.
P-A-R-A-N-G?
Yeah.
Yeah, that's usually parallactic angle.
Do you know how we can use that? Or is it relevant? Probably not.
This is for the where
Oh, this
you
is in terms of galactic distance. Like, is this like parallax in terms of like when the object's position was recorded versus like position was recorded in the catalog versus when it was observed? Like, is that the
No, parallactic
parallax?
angle is telling you, let me see if I can explain. Relative to north and east, what is the direction that points from the target directly to the horizon? Because that's the direction of differential refraction caused by the Earth's atmosphere. That's called parallactic angle.
Oh, okay.
And that's relevant every time you're taking any kind of spectrum or anything like that.
I see. Okay. Yeah, I thought it's parallactic angle, like, the way we measure parsecs. That
Yeah,
parallax.
no, that's parallax. This is parallactic angle is different from parallax.
I see.
They both have to do with apparent offsets, In one case, it's caused by the apparent motion of the Earth around. One case, it's caused by the motion of the Earth around the sun, but in the other case, it's caused by differential refraction of the Earth's atmosphere.
Right.
Parallax means the apparent change of position. That's all parallax means. But in our school science experiments, you have to move your head from side to side until there's no parallax, right? So so parallax just means apparent motion of an image. Now, so when you have the parallax from the Earth's motion around the sun, the apparent equal and opposite motion of a nearby object, you can use that to measure distance, right? And that's where the name parsec comes from. It's parallax of 1 arcsecond. Whereas in the case of parallactic angle, it's what happens is if you imagine looking right towards the, directly overhead towards the zone, what happens is all light rays go straight through. There's no bending. It goes right through the atmosphere. Right? It's entering the vacuum air interface perpendicular to the interface. But if you're looking at closer to the horizon, then what happens is red light bends more than blue light.
Right.
So the atmosphere acts like a little prism and creates a little spectrum of every object. And the orientation of that spectrum is from up to down, right? Because the orientation of the spectrum points from the object towards the horizon. So for example, if you're taking a spectrum of an object, like we are doing, you want to align the slit along the parallactic angle, because then the blue light from the object and the red light from the object enter the slit. If the slit were perpendicular to that or at any other angle to that, then of course we would lose light.
All right. Yeah, that makes sense. Okay, I found two variables called shift 0 and shift 1. And I think they are the ones that give us the offset. Yeah,
that's exactly
the descriptions.
Right.
Yeah, the descriptions read shift to fix low X slit end and shift to fix high X slit end.
Yeah, and the sum of those two gives you the length of the slit.
I see. Do you know what unit these might be in?
Arcseconds, I believe.
Okay.
I believe that's right.
Yeah.
An easy way to do this, I'll tell you, is if you took a mask and you plotted all of these as rectangles, because the width of the slit, the width is fixed for a given mask, and then typically it's 0.8 arcseconds, 0.8 or 1. But let's say, independent of the width of the slit, if you took all the rectangles for a mask, you plotted them, basically you should see where one rectangle ends, the other one's next slit starts, etc.
Right.
Would be a good sanity check.
Still haven't found the angle of orientation for the slits.
Oh, that's known for each mask. It's already known for every mask.
Yeah, but it should be somewhere in the FITS file, right?
I don't know if it's in the FITS, if it's stored in the FITS. It might be. We have this information for every mask.
Not sure if it's in the FITS file. Yeah.
Okay, I don't know if it's. I don't think it's in the FITS file. That's my recollection is it isn't, because it's a fixed. I mean, there are some masks where different slits have different PAs, position angles, or all the slits have a position angle that's different from that of the mask. But this information's in the mask design file, so we know this.
Oh, is it PA? Okay, the file has a bunch of headers with PA.
It is in the chip. It is in this header.
Okay, so let me read it out. There's a variable called objpa, and the description reads object PA on the sky, There's one called slit PA.
Slit PA is what you want.
Yeah,
Object
I think
PA
that
is,
must be,
yeah.
slit PA on sky.
Okay, the object PA is if instead of observing stars, you're observing galaxies that have a finite extent, shaped like an ellipse, then it's that information. But slit PA is what you want.
But also there's another called mask PA.
Yeah, which could be different from slit PA. That's what I mean.
Yeah.
So most cases, slit PA and mask PA are the same, but in general, the slit PA could have a slight angle from the mask
They
PA.
are different for this file, at least the one I'm looking at.
What mask
So
are you
the
looking at?
I'm looking at M33D2A. I'm looking at slit 12, and slit PA reads 100, and the mask PA reads 110.
Yeah, so they could be different by up to 30 degrees, plus minus 30.
I see.
Because what happens is, the reason we make it different is sometimes the mask PA controls which stars are going to be in the slit. The mask PA controls which stars are going to be on the mask. But the slit PA, you want to make it parallel to the parallactic angle.
I see.
And that parallactic angle changes depending on when in the night you're observing the mask.
Yeah, of course.
So those
So
sorts of planning.
I guess we should use slit PA then.
You should definitely use slit PA, not mask PA.
Yeah.
In fact, if you draw a rectangle using the mask PA, you will note, or if you draw a line using the mask PA, you'll see that or if you draw a rectangle using the mask PA, you'll see all the slits are contained within a rough rectangle, whose, that's given by the mask PA. But the slit PA is what matters for the actual drawing of the slits.
Right. And the width of the slits are fixed by the milling bit, I suppose.
No, we can specify that. So we usually use 0.8, but in some occasions, and basically in the DEIMOS disk, in the M31 disk and M33 disk, we invariably use 0.8. There's a minimum width to the slit that's set by the milling bit, but you can choose a width that's bigger than that.
See, I don't see that information here.
No, that information won't be there. Use 0.8.
Okay, we'll use 0.8.
Yeah, 0.8 is what we used for our entire M31 disk survey and M33.
I'm not sure if, I could even do this because, we have to check because, like I said,
the image resolution. The
image resolution is probably lower. Exactly.
Yeah, to really match these things, one would have to, what's the way to do it? I mean, one can always degrade resolution, right? But because we don't have complete information for the DEIMOS mask, there's no way to degrade the resolution because we don't know what's going on in the surroundings. So the best thing we can do is just do a good comparison, position by position. I wouldn't use a rectangle or bother with that.
Just out of curiosity, there's another header which is called DX, and the description reads offset from Caleb slit trace.
I think I know what that is. So remember that in the raw frames, the slits are horizontal, and spectrum runs vertically. So DX is a spatial offset. And what it is the actual location of the extraction window relative to where the design file said it should be.
Oh.
Now,
okay.
For serendips, that might be quite large, but for targets, it should be relatively small.
Okay.
I believe that's what DX is. Caleb slit is, that's based on the mask design file where the extraction window should be, I believe.
Yeah. I think it's probably best to proceed with the 2D spectra. And I think from this discussion, we can agree that we should try collapsing the 2D spectra without adding the sky spectra first.
Yeah.
Just doing a median subtract moving median subtraction first and then collapsing it, and it should ideally show, it should ideally be 0 at around the location of, the emission lines.
If we're using a
Because,
mean, if the sky is using a mean, if it's using a median, it may not be.
right. And then we can add it in.
Yeah.
If we see that, it's not 0, we can add it in. And if it is 0, we can just work with 1D spectrum.
Okay. There is some change. I mean, when you do those histograms, you can see the ones that are. No dome flats. Sorry, I'm answering the.
Yeah. Yeah. Sorry, was that?
Yeah. So the histograms that you created shows that when the ones that are marked by hand do tend to have higher image values. It's just that they're not systematically like they both have a peak with very low H alpha intensities. And that's the part that surprised me.
Yeah, that's exactly what happened. Yeah.
Now, one thing, I don't know if there's any way to do a sanity check on the positions, if there's some kind of offset, then that would produce this kind of symptom. If we are comparing apples to oranges, if our slit is actually in a different part of the sky than their map is, if for some reason, I don't know if there's how we can check this.
But so the way I see it, I don't know if, even if there's an offset, I don't know if it will be like more than 1 pixel.
So here's just a thought.
It would be tiny, right?
Yeah, 1 pixel would be tiny, but here's a thought. A few years ago, my student Lara Pritchard wrote a paper on stars with emission lines in M31. Okay, these are very strong H alpha emission lines. These are 2 flavors of stars. They're actually AGB stars with emission lines, and there are, main sequence BE stars, emission line stars of the spectral type B. So Lara Pritchard wrote this paper. In fact, just today, when we were looking at the raw spectra, we found a star with H alpha and calcium triplet emission lines. So what that could do, so since stars are point sources and they put out emission lines, even the bells are point sources that put out emission lines. I'm wondering if that can be used to match up the image with the spectrum. Because those are point sources where we know there's very strong H alpha emission. And we know their coordinates. What does it look like on the image? That might be a good check. In particular, if we see an offset between all 6 bells and Laura's stars are in the fat region. There are many stars with H alpha emission. I expect to see spots on the image at their location. Now, let's say on the H alpha image, you were to mark the positions of Laura's emission line stars, and you found that all of them were offset by, let's say, a few arc seconds. Let's say, I'm just making this up, to the south-southwest, then we would know why. That would be one explanation for why the correlation, you're not getting a good correlation between spectral versus image H alpha spectrum.
Again, I guess this will depend a little bit on the resolution. But still we should see bright spots, obviously.
Yeah, and so some of these are really strong sources, like the H alpha in the bells is very, very strong, and they're point-like. So
yeah, I mean, obviously these are like faint objects in the night sky, but I mean the images of diffuse H alpha emission,
it's even fainter. It's even
faint.
Yeah, and especially if they're point sources, stars tend to have, when stars have chromospheric activity of some sort, they tend, they show up as really bright H alpha spots.
Yeah.
So that might be
Well,
a way
actually,
to
that
rule out, way to rule
yeah,
out
I mean
coordinate
that
mismatch.
makes me wonder if we can, get any new information about H2 regions from our data, like apart from the diffuse H alpha, just the concentrated H2 regions, because the image, right, the image shows
Should have
H2
those.
regions, I think.
Yeah, and
I mean,
sometimes our slits overlap them, and that would be good to know when they do.
yeah,
Those may be our relics, actually.
yeah, exactly. In fact, like this is one of the questions that I got at the end of the AAA's presentation.
Yeah.
Somebody asked if we can identify H2 regions or supernova remnants in our data.
Yeah.
I
don't know
I
what
said,
I don't know what the
yeah,
filling
and I said
factor of those is.
exactly. I said, yeah, like so far we don't know how to identify that, but like, yeah, I mean, if the slit covers one of those regions, we probably have some data on it, like, but we don't know how to identify them. Like we haven't been able to identify.
So if other people have identified them, which they've identified.
Exactly.
Zach Jennings wrote a paper on supernova remnants in the FAT survey region. They actually used Hubble imaging to look at colors to identify supernova remnants, colors and morphology of structures too. And of course, H2 regions have been mapped out throughout M31, M33. So we could check to see if those are the ones that have, whether those have unusual emission lines, like rare emission lines or unusual emission line ratios, things like that.
Yeah, that seems like a nice long-term goal.
Yeah.
I mean, for now, I am trying to meet this goal because, like I mentioned in the email, because if we can get this thing sorted, then it's much easier to justify this sorting of this as having H alpha emission and not having H alpha emission, which is originally why you suggested it.
Yeah,
so whatever we decide to put in the paper, like this helps. Like this
will help. This will help. I agree.
This really helps us and gets us one step closer to the paper.
And and the referees always like when you do some kind of sanity check for comparison. That is, we are making one measure of it. Other people have made a measure of it. So it allows us to compare to the literature.
Yeah, exactly. I guess I should probably send Liv an email because I don't think they're checking the Slack messages. But yeah,
okay.
I'll probably try to set up a meeting
Liv is going
with
through
them.
a busy period. Yeah, they prelim exams or something like that.
Oh, I
think
see.
so.
See, that makes sense. Anyway, I'll hop off now.
Okay.
Thank you, Raja.
Okay.
Yeah.
No problem. I'll sign off also. I know Manjuma was going through exams. I was going to, she had suggested I talk to her after her exams. I'm in, of course, I'm in Hawaii this week. So after I get back, I'll probably chat with her.
Yeah.
Okay.
Yeah.
Let's stay in touch, Rajita. It was good seeing you in Kolkata. And Anand was seeing you for the first time.
Yeah. Anand looked so tired.
Well, you were all so tired. It's the end of a long trip, right?
I know. Yeah, but you didn't look tired, though. I mean, but, like I said the other day, like you seem to have endless energy somehow.
Like, I do.
Yeah.
I don't feel that way.
You do.
But
Yeah, and I'm used to long trips like that. Anand from there had gone on to
Amritsar.
Amritsar and then Chandigarh.
Oh, cool.
So, and you know, it was his first visit to India since he was 8 years old or something like that.
Really?
Yeah, so his first visit since he, you know, as an adult. His parents had brought him when he was a kid
Oh my
more than
God.
once. More than once, yeah.
I had no idea. I thought he visited occasionally. Wow.
You know, so last time he came, it was, see, he's 23. I think last time he came was 15 years ago, or he was 9 years old, or 14 years ago, or something like that.
Oh my God. Wow.
Yeah. All right, I'll hang up.
Yeah.
I will.
Yeah, I'll stay in touch. I'll, try chipping away at this.